Hi, welcome to our course about Practical Windows Forensics for Beginners. Prerequisites: Windows 10 or 11 system. No experience needed, you will learn everything you need to know. What will you learn? Basic concepts of computer forensics and Windows operating system architecture. Techniques to collect and preserve evidence from a Windows system, including memory and disk forensics. Steps to analyze Windows event logs and other artifacts to identify evidence of malicious activity. Tools and techniques to recover deleted files and identify hidden files and folders. What should you do? Before watching your video, download the resources.7-zip file related to the video and extract it. This zip file has every tool you need. Take notes while watching the videos to help reinforce the key concepts and techniques covered in the lectures. Pause the videos at key moments to review the material and ensure you understand the content before moving on. Attempt to replicate the techniques and exercises covered in the videos on your own Windows system to gain hands-on experience. Ask questions and seek clarification on any topics that are unclear or confusing. Continue learning and exploring advanced Windows forensics concepts beyond what was covered in the videos to expand your knowledge and skills. Congratulations on taking the first step towards learning something new. Remember, progress takes time and effort, but with determination and dedication, you can achieve anything. Keep learning. Hi, in this course, you will learn about the Windows Registry. I must say with regret that this presentation contains long text. I will do my best to prevent you from getting bored. Let's start. Registry Forensics Part 1. Although many end users are unaware of it, the Windows operating system consists of a multitude of components beyond its desktop, Windows, and applications. Some of these components are essential for the proper functioning of the operating system, while others are necessary for newly installed software and hardware to operate. One key aspect of the Microsoft Windows operating system is that all settings, software, hardware, and user-related values must be stored within the system. This crucial information is kept in a database known as the Windows Registry, which acts as a centralized repository for all configurations. The registry holds data for both enabled and disabled operating system features, as well as for many applications that utilize it. Microsoft Windows has integrated the Windows Registry into its operating system since Windows 3.11, making it a crucial component. The Windows Registry stores not only the configuration and settings of the operating system, but also the preferences for running services and installed applications, providing users with the ability to customize their system. Within the registry, all values pertaining to settings, software, hardware, and users are stored in Microsoft Windows systems. Anytime a computer setting is modified, a program is installed, or an installed program is uninstalled, the registry is updated to reflect the changes. This ensures that user modifications to their systems or installed software are retained when the computer is restarted after shutting down. The Windows Registry stores a vast amount of entries, and manually reviewing each of them can be time-consuming. Therefore, for forensic analysis, an analyst needs to know where to look for potential evidence. Even if we remove hardware, software, and driver components from our computer, they can still leave behind data traces. The registry contains valuable information, making it a significant source of information for digital forensics investigations. Some of the valuable information that can be found in the registry are usernames, running programs, plugged-in USB devices, devices defined in the system, computer names, recently used software, personal settings, browser preferences, system configuration information, network share information. Accessing registry records. The most basic tool for editing, viewing, and searching the registry is regedit.exe. It can be accessed via 1. Type regedit in the search box, then open it. The second way is go to Start, type Run, Enter, then in the search box type regedit and OK. When you run regedit, you will encounter a page like this. These are called root keys, and there are 5 of them. Registry structure. Registry is a hierarchical structure consisting of keys and values. Keys are located on the left side and the values are located on the right side, often displayed as 0 or 1. The registry structure is classified in a directory-like manner, consisting of root keys, subkeys, and values. There are 5 root keys in the registry: HK classes root, HK current user, HK local machine, HK users, and HK current config. Knowing which information is kept under which keys gives us great advantages when conducting an investigation in the field of forensic informatics. We will now examine what information is found under root keys. HK classes root contains information related to software, settings, shortcuts, and all other user interfaces. If this section is deleted, Windows will still work, but none of the files will open. Moreover, this section contains information about file types, OLE, object linking and embedding, and file associations. HK current user. HK current user is a registry here in the Windows registry that contains configuration information for the currently logged in user. This includes preferences, settings, and other data related to the user's desktop, applications, and other software. It is important to note that changes made to the HKCU here only apply to the current user and do not affect other users on the same machine. HK local machine. HK local machine contains computer-specific configuration information, including hardware-dependent settings that may vary from one computer to another. This section hosts system software and settings, which are applied to all users who log in. It also contains configuration and settings that the system uses during startup. There are 5 keys within HKLM that are important for system configuration and management. Our first key is System. System contains system configurations such as computer name, system time zone, and network interfaces. Software contains settings and configurations for installed applications and operating system services on the system. Security contains the security policies in the system. SAM stores security account manager and user group security information. It contains the username, the user's unique SID, and the hash of the user's password. Hardware contains information about hardware devices connected to the system. This information is stored during system boot. In other words, BIOS. HK users. HK users is a registry key in Windows that contains subkeys for each user profile. Each subkey holds settings specific to the user, identified by a unique security identifier. When a user logs in, their settings are loaded from their subkey under HK users and saved back to the registry when they log out. While primarily used by Windows, advanced users and system administrators may modify user settings or troubleshoot issues using this key. HK current config. HK current config is a Windows registry here containing hardware configuration data. It is actually a subset of HK local machine root key and dynamically generated at boot time based on the current hardware profile. The registry here is a symbolic link to the appropriate hardware profile subkey in the HKLM here, and changes made to HKCC will be reflected in the corresponding subkey. Although it's not directly accessed or modified by users, some applications and drivers may modify values in HKCC during installation or configuration. Import, export, registries. I will show you an example of import-export process. Click on Start and type regedit. Enter. Yes. For example, let's export this example subkey. Enter. This subkey shows the time zone information of the local computer. Right-click on the subkey, Export. You need to select the export range. I will keep it as it is because when you choose all, it exports the entire branch. In this case, the HK local machine root key with its all subkeys. We don't want that, right? Type the file name, then choose the folder you want to save. Click Save. Let's open our folder. You can view the contents by right-clicking and selecting Edit. If you want to change a record, you can do it. After that, save it with Ctrl S. For example, I want to change Turkey to USA. Let's save it. If you want to merge changes with original registry records, you can double-click on the registry file. Oh, there's a warning box. Let's read it. Adding information can unintentionally change or delete values and cause components to stop working correctly. If you do not trust the source of this information in C timezone.registry, do not add it to the registry. Are you sure you want to continue? I will click No. We should avoid merging registry records because it can cause conflicts, errors, and potentially harm the stability and security of the system. Merging can overwrite or delete existing registry values, leading to unpredictable behavior and system crashes. This video is over for now. See you on another video. Hi, in this video, you will learn how to analyze Windows Registry manually. Registry Forensics Part 2. Learning Computer Operating System and Version Information. This information is located at this key: HK Local Machine, Software, Microsoft, Windows NT, Current Version. From this registry record, we can deduce that the operating system is Windows 10, Home, and single language. The current build number is 22621. Learning the time zone of the computer. This information is located at this key: HK Local Machine, System, Control Set 001, Control, Time Zone Information. From this record, we can deduce the time zone of local computer is Turkey Standard Time. Learn installed software. We can find this information at HK Local Machine, Software, Microsoft, Windows, Current Version, Uninstall. These registry keys can be used to identify potentially malicious software and recover deleted or uninstalled software. By analyzing the key, a forensic analyst can determine the names, versions, installation dates, file paths, and uninstalled strings of each program. This key is a valuable resource for investigating Windows systems and can provide insights into software changes made over time. Learn about printer drivers installed in the computer. This information can be found in HK Local Machine, Software, Microsoft, Windows NT, Current Version, Print, Printers. You can find the values for printer drivers in this registry. Learning the network SSIDs that the local computer connected. This information is located at HK Local Machine, Software, Microsoft, Windows NT, Current Version, Network List, Profiles. You can find the list of SSIDs, in other words, Service Set Identifier, that you recently connected. This key is important because it can provide insight into the network connections that a system has made, including wireless networks, VPN connections, and LAN connections. Learning USBs connected to computer. This key is located at HK Local Machine, System, Control Set 001, Enum, USB, Store. As a forensic analyzer, this key is an important registry that can provide valuable information about USB storage devices that have been connected to a Windows system. The key contains information about the device's vendor, model, serial number, and other identifying information. This information can be useful for investigating data theft, malware infections, and other security breaches. Learn the computer name. Learning the computer name we examined prevents the name confusion in the log records. It means that you can qualify the evidence you collect about the computer with the name of the computer. This information can be found at HK Local Machine, System, Current Control Set, Control, Computer Name, Computer Name. Learning MRU lists. MRU, the most recently used list, contains entries made due to certain actions performed by the user. This registry maintains list of items in case the user returns to the files in the future. This information is located at HK current user, software, Microsoft, Windows, current version, Explorer, run MRU. This is a registry key in Windows that stores a list of recently run programs using the run application. This information can be useful in forensic investigations to determine the user's activity on the system. Learning recent docs shows the most recent documents used or opened on the system. Extension for all files in this registry is .lnk. This information is located at HK current user, software, Microsoft, Windows, current version, Explorer, recent docs. This subkey stores a list of recently accessed documents which can be useful in forensic investigations to determine a user's activity on the system. Finding out Internet Explorer URLs visited. This information is located at HK current user, software, Microsoft, Internet Explorer, typed URLs. This is a registry key in the Windows operating system that contains a list of URLs that a user has typed into the address bar of the Internet Explorer web browser. Notice that I'm saying the Internet Explorer, not a modern browser like Edge or Chrome. So if Internet Explorer isn't installed in a computer, this registry location cannot be found. Learning the devices plugged into the computer. If a hardware is mounted to a computer, like CD-ROM, DVD, hard drive, flash memory, it will be recorded in the registry. This information can be found at HK local machine, system, mounted devices. This is a registry key in the Windows operating system that contains information about storage devices that are currently mounted or have been previously mounted on the system. The values in this subkey contain information such as the device's unique identifier, its mount point, and the drive ladder that has been assigned to it. Warning! Before we move on, I would like to warn you about there's a possibility that some of these registries may not be available on your system because of differences between versions and build numbers in various Windows systems. This video is over. In the next video, we will get through some of these registries with regedit. Let's further explore some of these registries together. I strongly recommend you that you should spend some time while exploring these registries on your own. Go to Start, then type regedit. Enter. I prepared some keys to learn more about them together. Our first subkey is uninstall. I will copy and paste it to the regedit. Enter. There are lots of subkeys available in here. Let's scroll below. You can see there are some known applications like 7-zip and XAMPP. When we scroll a little bit top, there are lots of subkeys. Start with B2. Let's see what are they. I think these are DLLs of NVIDIA's GPU driver. Let's go back to our more known app, which is 7-zip. In those registries, you can infer some details as I mentioned before. These are application name, version, generally installation date, but this one doesn't include it, install location, and uninstall strings. I want to look quickly to check if anything takes my attention. I see lots of packages related to .NET Framework and some applications like VMware or drivers for printers. Our second subkey is run MRU. Copy the path and paste it on the box. I want to explain this registry with an example. You can see some data in here. There writes dxdiag and a Google URL. As I told you, this registry contains commands ran in run application. Go to Start and type run. Shortcut for this application is Windows R. I will type Chrome in this box. Then OK. Chrome has opened. Now F5 refresh the regedit application. You can see the new command added in this registry. Our third subkey is recent docs. Let's copy and paste it here. Enter. There are lots of values in here. Extension for all files in here is .lnk, which represents shortcut files. But you can see some of files keep the extension as it is. It depends on the configuration of a specific application. Under the recent docs key, there are some subkeys as you see. These are categorized recent files. When you investigate a computer, you should check both main recent docs key and its subkeys one by one. Let's look some of them. Let's click on 100. We can see that it is aaa.bin and it also indicates it is aaa.lnk. Let's go to another value, for example 11. Let's scroll to below. It says build docker.lnk. It means it is a Docker file. You can click on any subkey and see them categorized. For example, let's click on this one. Resources.7zip. Our last subkey is mounted devices. Let's copy the path and paste it here. You can see there are two local disks, C and D. There are currently or previously plugged in 4 flash drives in here. Let's open one of them. It says USB-S store disk when, probably this means vendor, and it is SanDisk. You have learned how to analyze Windows registry manually. This video is over. See you on another video. Hello everyone. In this video, you're going to learn how to analyze RDP Cache files. What is RDP Cache? RDP Cache is a file that is saved in the initiator's local disk during an RDP, Remote Desktop Protocol, session. The RDP Cache file is used to increase the speed of the RDP session, especially when connecting over slow or low bandwidth networks. Forensics value of the RDP Cache. RDP Cache can be a valuable source of information for investigators trying to piece together an attacker's actions on a compromised system. The RDP Cache file may contain screenshots taken by the attacker during their session. These screenshots can provide valuable insight into the attacker's activities, including what files they accessed, what commands they executed, and what actions they took on remote system. RDP Cache file location. In Windows 7 and above, we can find the RDP bitmap cache in the following directory: C, users, the username, app data, local, Microsoft, terminal server client, cache. There are potentially several different files under this folder. The first will be a file named bcache.bmc, and the others will be cache.xxxx.bin. X's are replaced by numbers start with 0000 and increasing in sequence. For example, cache0.bin, cache0001.bin, etc. The bcache file extension is appended with the numbers 2, 22, or 24, which represent the quality of the images. We know that the higher the number, the higher the quality of the bitmap images produced. Our system creates a separate cache file for each of the RDP sessions. Timestamps can be used to distinguish these files from one another. Parsing RDP caches with BMC tools. BMC tools is written in Python and can be easily run on both Linux and Windows via command line. We can parse the RDP bitmap cache files using BMC tools and continue our investigation. Let's look at the command line. Python, the standard phrase for executing .py files. S flag is used to specify the source directory. D flag is used to specify the output directory. And here you can see we have successfully exported 526 files. RDP Cache Stitcher Usage and Analysis. Open the application and add your parse folder as a new case. Then combine the bitmaps. Now let's apply what we learned. I want to show you where the RDP Cache files are stored. Go View and check Hidden Items. Then go to C, Users, the username, then App Data, Local, Microsoft, Terminal Server Client, and Cache. Here you can see bcache24.bmc file and the three cache.bin files. It means that we have established 3 RDP sessions before. For this video, I will use another RDP cache file. It's time to analyze the RDP cache files. First, we need to parse the RDP cache files with BMC tools. Let's type cmd over here and open a terminal. Then type python 3 bmctools.py and -h. We will specify the source directory with -s. We will also specify the destination directory with -d. If you want to limit the number of bitmaps we'll extracted, you can use -c 200 maybe, -v for verbose information, -o to extract the old bitmap data found in the bmcache file, which is used in Apple computers. We will use -b flag to provide a big bitmap aggregating all the tiles. Use -w to specify the number of tiles per line of the aggregated bitmap. Default is 64. Now let's clear the screen and type the command for BMC tools. Before we move on, we need to create the folder named output. Then run the command. We've just successfully exported 526 bitmap files. Let's look at them. The black screen might be related to the command line on the screen, and the blue ones might be the PowerShell. Let's keep scrolling down. Oh, I think these screenshots might be the output of a command run in cmd. I think the command might be ipconfig because we can see the address IPv6 local. So let's keep investigating. We can see the time, the temperature. I think these bitmaps belong to the Telegram application. Yes, we can see the Telegram, a person. We can see some messages and also the name that the attacker has spoken, Wi-Fi, a chat message. You can also open the bitmap by clicking on it. I think this is the bitmap from Microsoft Edge. And this is the website, CyberExam, I think. cyberexam.io might be the domain name. The review part is over. We can continue with the RDP Cache Stitcher application to combine these pieces together. Let's go back and open the exe of RDP Cache Stitcher. Click on File, New Case, and select Output. Loaded 526 tiles. Okay. As you can see, the bitmaps are listed here. There is the auto-place button, but I do not advise you to use it because it generally fails when combining the pieces together. Okay, let's start. For example, let's go here, left click, and left click again to drop it. And I think this is the correct piece for here. Also, this tool provides you a great option that I will show you in a minute. Left click on this square. When you hover your mouse over the bitmap, you can see that it completes. I don't think this is the correct piece. I will move on to the next one. And yes, this is the correct piece. Then I want to click here. Is this the correct piece? Or this one? Both seems true. But I think this is the true piece. If you would like to remove a bitmap, you can double right click on it and remove. This video is over. See you on the next video. Hello everyone. In this video, you will learn how to analyze recycle bin. Recycle.bin. Recycle bin is the folder where deleted files are temporarily stored on Windows systems. This file is located in the $recycle.bin directory under the main drive in every version after Windows Vista. This mechanism provides user with the ability to recover deleted files. The recycle bin folder is located at c$recycle.bin. If you can't see the recycle bin folder under the C directory, you can follow these steps. Go to File Explorer, View, Options, and View. Uncheck the option Hide Protected Operating System Files and check the option Show Hidden Files, Folders, and Drives. Recycle bin's forensic value. By default, deleted files on our computer are stored in the recycle bin directory, and after the deletion process, two different types of files are created in this directory. These are the files start with $I and $R. $I. This prefix is used for the information file, which contains metadata about a deleted file, such as its original file name, size, date modified, and the location it was deleted from. The $I file is associated with the deleted file and enables the recycle bin to display the original file name and other information when viewing its contents. The $I file is typically not recoverable as it only contains metadata and not the actual data of the deleted file. $R. This prefix is used for the recovery file, which contains the actual data of the deleted file. This file is renamed with a random alphanumeric name when it is moved to the recycle bin, and its original file name is stored in the associated $I file. These files are valuable sources of information during forensic analysis because they contain data about deleted files and the time of deletion. What happens when you delete something from recycle bin? When you delete a file from the recycle bin on a Windows computer, $R record is deleted, but $I record stays for a while. The operating system marks the space occupied by the file as available for use by other files, and the file's entry in the $I file is updated to reflect that it has been deleted. The $I file is typically overwritten as new files are created and deleted, so it is generally assumable that the $I file will be overwritten within a few days to a few weeks at most. Inside the recycle.bin folder. Below, you can see some files inside C, recycle.bin, and your SID. When we type the command dir, we can see the files listed in that directory. You can see that 3 of them starts with $I, and the 3 of them starts with $R. The extensions and the names are the same, except I and R. It means that 3 files in here are not deleted from the recycle bin. But when it comes to the PDF files in here, only the $I record are listed. So we can understand that these PDF files are deleted from the recycle bin, but since they are not overridden by the system, we can still see their $I records. Recycle.bin Analysis Tools. To parse the files located under the recycle.bin directory and obtain meaningful data, we need the help of tools such as refito2, regedit.exe, and $I parse. We will proceed using $I parse and refito2 tools. Refito2. The Refito tool analyzes the Windows recycle bin folder. Refito can extract the file's $I record deletion time, the original path, and the size of the deleted files. You can follow the instructions from the relevant GitHub page to download the Refugee tool. After downloading the tool, you will be presented with two exe files, refugee.exe and refugeevista.exe. The difference between the two exe files is that refugee.exe reads the info or info2 files in the recycled or recycler folder for the versions between Windows 95 and XP and also the version 2003, while refugeevista.exe examines the recycle.bin folder. We can see the help page for the Refugee tool with the comment below, refugeevista.exe-h. In this manual page, there are help options and the application options, -o to write output to a file, -x to write output in XML format, -z specify deletion time, -v to learn the version. You can run the Refugee tool using this command, refugeevista.exe and c recycle.bin and the related path, which is the SID of your user. You can view the output as a file using the -o option. You need to specify the output extension as you see here. $iparse. Another tool, $iparse, similar to Refugee, allows us to analyze the recycle.bin directory and parse information about files. The difference between two tools are $iparse tool doesn't show information about the equivalent $i value related to the file. The second difference is $iparse tool has graphical user interface. When you run the application, this interface will welcome you. You need to specify the full path to the recycle.bin in this blank, and here you need to specify the output directory. After you fill blank directories, click on Parse. If you want to display parse information using Excel, you need to set the extension name as CSV. After you open the file, you will see a table similar like this. Now, let's apply what we learned. I have tools available in this folder, and I will write cmd to open a command line. I want to find the folder where my recycle bin located, so I will go to C directory and cd $r and tab. Now let's type cd again, tab, and another tab. This is the SID of my user. Enter. Let's type dir. Okay. I will copy this directory. I will type cd, copy it. Okay. I will only show you the lparse tool not to extend this video any longer. Double click. Okay. Directory of the $i files. Paste it here. And the output file. Let's copy the directory here and paste it over there. And I will specify the extension to open it using Excel. Okay, let's parse. 6 files parsed. Okay. I will close it. Let's open it. In order to see the output properly, click on the column A, then go Data, Text to Columns, Delimited, Next, Next, Finish. Now you can extend the columns manually. All the details can be seen here. This video is over. See you on the next video. Hello everyone. In this video, you will learn how to analyze link files. What is the link file? Link files are shortcut files in the Windows operating system. These files contain the necessary information to access another data object and help Windows run faster. Link files can be created automatically by users or the operating system. These files contain a lot of data that can be useful for analysis, such as the file's original path, size, unit serial number, network share, and host MAC address. Forensic value of the link files. From a forensic standpoint, link files can provide valuable information that can help us during a digital forensic investigation or incident response. Link files can help us to find files that may no longer be available on the system. Link files may be stored on a USB drive or on a network share. By parsing the link file, valuable information about the file can be revealed. Link files location. On Windows systems, you can find the link files in the specific directories. One of them is C, users, your username, app data, roaming, Microsoft, Windows, and recent. And the another directory is Office and recent. You can find the equivalents of the same recent folders on Windows XP, C, Documents and Settings directory. You can see the screenshots in recent directories below. Analysis of the link file. Before analyzing these files, they must be obtained from relevant locations. After the files are collected, tools such as ExifTool, LeckMD, and TZWorks Windows Link Parsing utility can be used for analysis. We will perform the analysis using ExifTool and LeckMD. ExifTool. Run the tool without option to see the manual page. This is an exhaustive page, so I snip the output. When you run the ExifTool on any link file without option, it will give you information about the relevant link file. LeckMD. We can also perform the analysis using the LeckMD tool. I will demonstrate the usage of these tools at the end of this video. Analyze the output. After the process is completed, it presents a CSV file to us. I will teach you what kind of information are parsed with these tools. Now, let's apply what we learned. Let's go to the directory where our link files are present. C, users, your username, app data, roaming, Microsoft, Windows, and recent items. As you know, this is just one of the folders that we expect to see link files. When we look at here, we can see that there are 138 items present in this folder. For example, let's analyze the Excel file named ASD. Let's go to our tools directory and type cmd to open a command line. Our exif tool is in that directory. Let's type exif and tab. We will give this file's path as an input. Click here and copy the full path. Then paste it on the command line. You should add your file's name here. Then tab. Notice that the extension is .lnk. The rule is all shortcut files extensions are .lnk. I want to show you a critical point that when I click this file, the system will prompt and say that this file doesn't exist. It means that the user has deleted the file, but the link file associated with that file exists. And that's why forensic scientists analyze link files. So let's continue with our analyze and press enter. You can see the path for the link file here. And at the bottom, the file's actual location is also available. This is the byte of the link file, and that is the size of the main file. Timestamps on the top belong to the link file, but the following timestamps belong to the actual file. Drive type is fixed disk. Drive serial number is there. And lastly, the machine ID is here. Press enter. Now let's use another tool, LeckMD. Type LeckMD and tab to see the manual page. Let's clear the screen. Leck tab -f. Copy the directory of the shortcut file. then add our file name. Since I have so many shortcut files in that directory, I will only parse the previous file. But you can replace -f with -d and specify a directory name to list information about all files. Now I will write --csv and dot to generate output in our current directory. Enter. And it has created the CSV file in here. Let's double click. I will make this full screen. As you see, the output is chaotic. We can fix this by doing these steps. At first, select the first column, then click Data. Text to columns, delimited, uncheck tab and check comma, next, and finish. This time click on the corner and double-click the line between two columns. We have fixed the file. It's time to examine it. I have mentioned almost all of them. Some of these details are out of this training scope. I can see the MAC address of the system that created this file, and the vendor of the network card is unknown. This video is over. See you on the next video. Hello everyone. In this video, you will learn how to analyze jump list files. Jump list. Jump list is a feature available in Windows 7 and later versions that allows users to quickly access previously accessed applications and files. Windows creates two different types of jump lists: automatic destinations, custom destinations. Automatic destinations are jump lists that are automatically created when a user opens a file or application. Custom destinations are custom jump lists that are created when a user pins a file or application. Automatic destinations. This folder is located at C, Users, the username you logged in, App Data, Roaming, Microsoft, Windows, Recent, Automatic Destination. You can also access by typing %appdata, %Microsoft, Windows, Recent, and Automatic Destinations. In this folder, you can see files like this. Custom Destinations. This folder is also located at Recent folder. You can see the files inside Custom Destinations folder. Forensics value of jump list. Jump lists contain valuable information on user activity, including access files, programs, dates, and times. They can be used to build a timeline of events for investigations into computer misuse or data theft. Jump lists are useful in incident response and malware analysis, allowing investigators to identify which files and programs were accessed by malware and its source. However, jump lists can be easily manipulated or deleted by attackers and shouldn't be solely relied upon for evidence. Jump lists should be used in combination with other forensic techniques and tools to get a more complete understanding of the user's activity on the computer. Analysis of jump lists. After obtaining the files, we can perform the analysis of jump list files using any of these tools: glacmd, Jump List Explorer, Windows Jump List Parser, or Jump List View tools. In this presentation, we will discuss the usage of glacmd, Jump List Explorer, and Jump List View tools. Analysis of jump lists. Let's inspect this GitHub page. Before we move on with this slide, I want to show you the files inside Custom Applications folder. Let's copy the path for the Custom Destinations folder. Then, open a command prompt and cd paste. Here, you can see the format of the files present in here. I also want to show you the Automatic Destinations folder. Go back with cd ... then type cd auto, then tab. Enter. Dir. Same type of files are here as you see. Let's go back to our presentation. We will inspect this GitHub page in a minute. Look at the image on the right. This is the screenshot of this GitHub link. Each application has a unique ID. Unfortunately, ID values of some applications are not available in this repository. Let's click on the link. You can see the unique IDs and matching applications. For example, Paint starts with 0B, 3F, and goes on. When we look at the custom destinations folder, there's an app ID value that starts with D35610, as you see here. When we search the hexadecimal piece in the GitHub repo, we see that it coincides with the application called Steam. Now, let's reinforce what we learned with tools. Our first tool is Jump List View. Jump List View is a tool created by Nearsoft. To start using it, simply double-click the exe file. After running jumplistView.exe, it scans the jump list on the only automatic destinations folder, not the custom destinations folder. Then, displays the information on this window. You can select one or more items with Ctrl and then export them as a TXT, CSV, HTML, or XML file. You can also copy the selected items with Ctrl-C and then paste the data into Excel or another spreadsheet application. I will show you how you demonstrate it. I copied the items and now with Ctrl-V I will paste it. To make this page good looking, you can extend the column width manually. While using Jump List View tool, we can get a lot of information about the jump list by double-clicking on any jump list file. Some of the information we can notice are file name, full path, and the application ID. You can search for this application ID to learn which application created this file. I don't recommend you to use this tool because it doesn't parse files inside custom destinations folder. The next tool we will use is the Jump List Explorer tool included in S-Tools. Jump List Explorer helps a hacker or crime scene investigator to analyze jump list data. Jump List Explorer provides a summary of jump list data and shows which files the user has recently opened, which applications they have used, and which folders they have accessed. We can run the program by double-clicking it. Click File, Load Jump List. We can move to the relevant directory and select all files inside here. I will click Ctrl-A, select all, and open. I will ignore them. Click OK. These are the files from Custom Destinations folder. I will go back again, File, Load Jump List, go one folder back, and I will write Automatic Destinations. Ctrl-A, and open. Now we have loaded all the jump list files. After loading the relevant files into the program, we can see the jump list type, the app ID, and its description. When you click one of the applications, for example, let's click on Microsoft Visual Studio Code, it will update the section below. You can see the list of jump list files related to the application you specified. You can click File, Export, Link Files, to export the files you listed, of course if they are not deleted. I click Desktop, Jump Tools, Make New Folder, Export it, and OK. When I come back to this directory, you can see the files. I want to click on the first one, and here is the file we just exported. Our last tool is glek-md. We can open a command prompt in this directory. Type glek and tab. After running it with no option, the information about the tool appears. In order to parse the jump list folders, you need to write a command like this. glek tab -d to specify a directory. C users username app data roaming Microsoft Windows and recent. You need to stop in here This exe will find both automatic destinations and custom destinations folder in that directory. Later, you need to type --csv and the output directory. First, you need to click here and then copy the path here, paste it, then enter. After the command is run, it performs the parse operation and presents us two CSV files. Let's check our folder. Here, there are two Excel files. One is automatic destinations and the second one is custom destinations. I strongly advise you to further explore these tools yourself. This video is over. See you on the next video. Hi, in this video, you will learn how to analyze UserAssist key. What is UserAssist? Windows systems have a database that stores important operating system and application configurations. This database is called the Windows Registry, and it consists of keys and values similar to folders and files in a file system. UserAssist is a key located in a section of the registry that records the execution history of programs frequently run by a user. Values such as file name, last execution time, and execution count can be found in the UserAssist key. Forensic value of UserAssist artifacts. UserAssist artifacts are a valuable source of forensic evidence in digital investigations. They can help investigators reconstruct a user's activities and identify suspicious or malicious behavior. UserAssist artifacts can provide information about program execution frequency, duration, and last runtime. However, they are not foolproof and should be corroborated with other sources of evidence. Location of UserAssist structures. The UserAssist source file is located at C users, your username, ntuser ... Artifacts can be found within the ntuser ... heaps at the following location: HK current user, software, Microsoft, Windows, current version, Explorer, UserAssist. Here you can see the key, UserAssist, and the subkeys in the regedit. Now let's reinforce what we learned with tools. Before starting our analysis, we need to export the ntuser ... file. We can use the FTK Imager tool. You can install this tool with a setup file which we provided you in the resources.7 zip file. FTK Imager is a digital forensic software tool commonly used by law enforcement and computer forensic experts to create forensic images of digital media. These images allow investigators to capture a copy of the contents of a storage device, including deleted and hidden data, and safely analyze it for evidence gathering in legal proceedings. Click File, Add Evidence Item, Logical Drive, Next, See, and Finish. Expand the trees until you see root folder. Then click Root, Users, Emir, which in this case your username. Scroll to the bottom. Right-click on ntuser ... file and export it to a distinct directory. Okay. We needed to use the FTK Imager tool to export the ntuser file because this file is always used by a process, so we are not allowed to access it. I mean, we cannot directly copy and paste it here. Now, we will use the Registry Explorer to extract UserAssist artifact from ntuser file. The good thing about this tool is it allows us to live monitor system files only if we run it as administrator, but this is not a feature we use in this video. Double-click the Registry Explorer application. You can easily drag and drop the ntuser file. Click No and Yes in order. Here, there are two options. First one is to go to the registry location of UserAssist by moving to Root, Software, Microsoft, and blah blah. Or you can directly click Available Bookmarks, scroll to the bottom, and expand the UserAssist. UserAssist is our key. There are 9 subkeys for this key, as you see over here. We will look for the subkey which has more than one count values. I will keep expanding the subkeys. We've just found the useful subkey. Click on Count. Let's make this full screen. We can sort the run counter in ascending order. We can analyze valuable information about related programs. Available data columns are run counter, focus count, focus time, and last execution time. Focus count is a number indicating how frequently an application is brought to the foreground. This value can be used to determine how often an application is being used or which applications are more popular. Focus time. Focus time is a time interval indicating how long an application has been used in foreground. This value can be used to determine how intensively an application is being used or which applications are being kept open for longer periods of time. These two values are important for understanding how frequently and how long an application is being used. They provide significant insights into which applications a user is focusing on and can be used by digital forensic investigators in analyzing user behavior. Now, let's talk about the program over here. This program name's data represents the sum of these all programs. Let's examine a program, Telegram. The run counter is 27. Focus count is 99. And focus time is 51 minutes. And the last execution time is 15th of March. Last but not least, I must mention when these records are refreshed. UserAssist records are not reset each time you shut down your computer. However, the frequency of updates to the records depends on how often the user uses their applications. For example, if an application is not used for a long time, the UserAssist record may not be updated. This video is over. See you in the next videos.